Really excited to be here and hear about all the awesome work that everyone in this room is doing, and excited to share a little bit of what I'm working on as well. Thank you to the organizers for having me here, and thanks also to Hannah from Mozilla for connecting me with the folks who organized this conference. So my name is Mehan, and I work for an organization called Mozilla. A lot of you guys may know us for our work on the Firefox web browser, which is a free and open source web browser. But we do a lot of other work at Mozilla as well that has nothing to do with web browsers. And so we have a number of programs and things that we run having to do with things like decentralization, open innovation, privacy, security, et cetera, et cetera. And the title of my talk today is Community Networks Past, Present, and Future. And in this talk, I'm going to kind of talk a little bit about the history of community wireless networks and provide kind of an alternative history of the internet and of networking technologies. Then I'm going to talk a little bit about how community networks are being used today and some of the problems that community networks are solving today. And then finally, I'm going to talk about a project that I'm working on at Mozilla, which is called the NSF Wins Challenges. So before I get started, just kind of a quick note on terminology and the way that I'm going to be using terminology in this talk. And so when I use the word network, I'm going to take kind of a broad definition of network, and there's really kind of two different types of networks I'm going to be talking about. So the first type of network is end-to-end networks. So these are technologies that kind of connect people, sometimes over long distances, using computer networks. So you can think of these as being technologies like the internet and technologies like it. And then the second kind of network that I'm going to be talking about is last mile networks, last mile technologies. And so these are smaller networks that kind of connect people with larger networks. So you can think of these as smaller networks that you might use to connect to the public internet. So for example, the Wi-Fi network I was having difficulty connecting with earlier, that's a kind of last mile network that connects me up to the public internet. And then finally, I want to talk a little bit about my definition of community networks, or how I'm going to be talking about community networks. And so on the panel this morning, Francis had kind of drew a line in the sand between amateurs and professionals. And I think this is kind of a similar distinction. When I talk about community networks, I'm going to be talking about networks that are built by non-professionals, networks that are built by people like hobbyists, artists, activists, people who are kind of doing this in their spare time, not in a professional capacity. So to kind of start out, I want to talk a little bit about the history of the internet and the way that we talk about the history of the internet and the way that we kind of conceive of the history of the internet. And this is something else that was kind of alluded to on the panel this morning as well. So there's this kind of dominant history of the internet, and we're all probably pretty familiar with it, right? And it goes something like this. In 1969, the Department of Defense, the Advanced Research Projects Agency, ARPA, built something called the ARPANET. And that kind of was refined over time and evolved into a few other things. And it eventually ended up as something called NSFNet, which was run by the National Science Foundation, which was a network used to connect all of these different research universities. And then finally, around 1989, 1990, those technologies were rolled into what we now call the public internet, which was a network that was kind of open and available to members of the public. And so one thing I think that's important to acknowledge about this history, and something that we should think about when we're thinking about this history, is that between those years of 1969, when ARPANET started, and 1989, when the public internet opened, there were all of these networks, but they were available to very few people, right? And so here we see a map of ARPANET in 1988. So this is pretty late in the game for ARPANET. This is just a year before the public internet was kind of opened for business. And you can see here, there's a few dozen sites around the country, and that's pretty much it. So networks like ARPANET and networks like NSFNet were really only available at big institutions, right? So research universities, supercomputing sites, Department of Defense contractors. So if you were at a place like MIT or Stanford, you would probably have access to these networks. But if you weren't, you probably didn't have access to these networks. Maybe you had heard about them, maybe you'd read about them, but you probably hadn't actually gotten hands-on and been able to use them. And so one of the things that I want to talk about in this talk is kind of an alternative history of what happened between those years of 1969 and 1989. There were a lot of other networks. There were a lot lot of networks that people who were not a part of ARPANET and were not a part of DARPA used and built and maintained. And I think that looking at some of those networks provides kind of an interesting alternate history and an alternate way to think about the way that the network was built and evolved over time. And the point of this, I think, is that if we really examine this history and we think about this as a history that also feeds into the development of not just the internet, but a lot of other networking technologies that we all use and rely on today, we can start to see that people like hobbyists, hackers, and activists were kind of equally important to building networking tools over time, in some cases just as important as the academics and researchers and government employees and other folks who are kind of a part of the dominant history. So there's three specific examples that I want to talk about today, three hobbyist-built networks, each of which I think was kind of radical in their own way. So the first one I'm going to talk about is called Community Memory, and Community Memory was built in 1973. Next I want to talk about Usenet, which came online in 1980. Then I want to talk about a network called FidoNet, which was built in 1984. And then finally, I want to talk about a network called Echo, which was built right here in New York City in 1990. So community memory is the earliest of the historical networks I'm going to talk about. It was built in 1973, and it was built by an activist collective in San Francisco called Project One. And so the Community Memory Project began when a woman at Project One named Pam Hart, who was a graduate of the UC Berkeley computer science program, but also an activist and was involved in a lot of other things kind of happening in San Francisco at the time. Through some connections and people that she knew, she got a hold of a supercomputer. It's important, I think, to appreciate the fact that in 1973, a supercomputer is something that very few people had access to. This was a huge machine. It was 24 feet long. It required 23 tons of air conditioning just to run, to keep the machine cool. But these guys had access to a warehouse space in San Francisco. And so what they did was they installed the supercomputer in the basement in San Francisco. And once they got it up and running, they were kind of spitballing different ideas about what they might do with this thing. And so here you see a picture of what they ended up doing. And so they basically connected that supercomputer to a teletype machine across the bay in Berkeley. A teletype machine is basically just like a glorified typewriter with a networking jack. It has a keyboard, you can connect it to a network, and then it has a big spool of printer paper, and it basically just continuously prints everything that's in the system. This was a pretty huge feat at the time, right? I mean, the distance between San Francisco and Berkeley is not so great, but using the fairly primitive technology that they had access to, they got it connected across the bay, and they housed this teletype machine in a record store in Berkeley. And so they were coming up with ideas now that they had the hardware and they had the network set up about what they might do with this. And they kind of looked for inspiration in this record shop, and they saw, you can see right behind them in this photo, a cork bulletin board, right? So people would go into the record store and they would post things on the bulletin board like items for sale or looking for a roommate. Basically anything you might use Craigslist for today, people were using pieces of paper kind of tacked up on this cork board for. And so they decided they were going to try to replicate that using software. And so they built this machine where all the information would be stored back in San Francisco in this mainframe that they had. But you could put a quarter in this machine and you could enter in a new message in the system, or you could just browse through the messages that were in the system. People use this in very predictable ways, pretty much all the ways that they were using the cork board in the record store, so trading recipes, looking for band members, things like that. But people also used it for some other more surprising things, right? So there were threads about affordable health care, where can you find an affordable clinic in the neighborhood and things like that. And so as the quote here, I think, kind of shows, the folks at Project One really thought of this project as being a logical extension of a lot of the community organizing work that they were doing at the time. And in terms of how the network was used, it kind of bore out that idea as well. So the next network I want to talk about is Usenet, and I think out of all of the historical networks that I'm going to talk about today, this is the one that will probably be most familiar to folks in the room. It was a pretty big network for its time. It's also been immortalized in pop culture quite a bit. Here you can see a screen cap from The Simpsons on which it's been featured many times. But Usenet, I think it was kind of a direct reaction to the fact that networks like ARPANET and NSFNet were only available to a very limited number of people. So Usenet was actually built by a number of graduate students in North Carolina, and they were students who were all housed at universities that were not like MIT or Stanford. They were universities that didn't necessarily have a lot of connections or a lot of money or a lot of government projects. And so they had heard about ARPANET, they had heard about NSFNet, but they didn't have access to these networks. And so they decided they were going to build their own network that could connect not just universities, but really anybody who wanted to get connected to a network and anybody who was interested in talking to folks in another location. And so what they ended up launching in 1980 was basically a very early example of a scalable distributed network that allowed data to move relatively quickly and very cheaply over long distances. So kind of a prototypical network in a way, if you think about the internet and other similar networks that we use today. And at its peak, Usenet had a user base in the millions, which is pretty huge for the 1980s. Tim Berners-Lee, the inventor of the World Wide Web, when he decided he wanted to announce the creation of the World Wide Web, he did so on Usenet, because that's where he thought he would find the largest audience of folks who were interested in that sort of thing. And the quote here is from Howard Rheingold, who's an important historian of this kind of era of computer networking. And I think it's really interesting because you can see there's a kind of like techno-utopian language in the way that he describes Usenet that's really similar to the way that people talked about the internet at the very beginning of the internet, right? This idea that a network like this could be inherently resistant to surveillance, or could be a way of kind of pushing back on things like censorship. FidoNet, built in 1984, is kind of a similar network in some ways. So in the 1980s, bulletin board systems, or BBS systems, were very popular. They're kind of like the earliest form of social networking. They were systems that you could dial into locally, and you could chat with other people locally on these systems. But they were all kind of siloed, and they were all separate, and they weren't kind of interconnected. And so FidoNet was a system that connected different bulletin board systems in different locations and allowed data to kind of hop from one bulletin board to another, and allowed data that way to kind of move over really long distances in a way that was a lot cheaper and a lot faster than most of the alternatives at the time. And FidoNet was built in 1984 by a guy named Tom Jennings. You can see a picture of him here. And Tom Jennings was an interesting guy. So he built FidoNet in a few weeks of downtime in between jobs. He had recently walked away from a job at Apple because he was kind of disenfranchised with the corporate life there. And he had a bunch of interests and things that he was involved in outside of technology that were also super interesting. So he was an avowed anarchist. He was an early participant in the queercore scene in the Bay Area. And if folks are familiar with the zine HomoCore, which was super influential at the time, he was a publisher and co-editor of that zine. And so he was a person who was kind of at the Venn diagram of a lot of different kind of political and cultural movements in San Francisco. And I think a lot of that ethos kind of ended up getting built into the network. And so one of the things he did that was a pretty radical decision at the time was he decided to just give the software away for free. He didn't charge anything if you were a hobbyist or just kind of a person who wanted to use it for personal use. And that's one of the things that allowed FidoNet to grow very quickly and very exponentially, was the fact that just about anybody could connect their BBS board using this software. At its peak, FidoNet had 50,000 nodes. And so you can see in the quote here, it was kind of neck and neck with the public internet in the early 90s, and some people kind of speculated about which of these two networks was going to end up becoming the dominant paradigm. So a hugely important, hugely influential network that I think has kind of been unfairly lost to history in a lot of ways. And it is still in use today by a very small group of people, primarily in Germany and Russia. So the last historical network I want to talk about is a network called Echo. Echo stood for East Coast Hangout. And Echo was basically a BBS board like the boards that were connected by FidoNet, so it was kind of an early social network. Echo was built by a woman named Stacy Horn right here in New York City, and you can see a photo of Stacy Horn here from the New York Times. So Stacy Horn was kind of an early participant in networks. She was an early participant in BBS systems. She had been a member of the Well, which was a very important BBS system in the Bay Area, and had kind of gotten enough of a taste of BBS systems to start to imagine what a different kind of BBS system would look like. And one of the things that frustrated her was the fact that most BBS systems were very male-heavy, and a lot of the culture on BBS systems was very male-heavy. And so when Stacey Horn built her own BBS system, Echo, she made the decision that she was going to give away accounts to women for free. So if you were a woman, you could join Echo, and you could use it for free for the first year. And then starting at year 2, you would get a discounted account, and you could get a pretty steep discount as well. And so by doing this, she completely shifted the gender balance on her board. So Echo had around 40% women on the board at pretty much all times, which if you compare it to just about any other BBS system from that era, the best, most BBS systems had maybe like between 10 and 15% female participants at most. And so it actually made a huge difference, not just in the makeup of the board, but the culture of the board and the kind of conversations that they had on the board. And Stacey Horn ran Echo entirely out of her apartment in the West Village. And so you've got to remember the time all networking was done over copper phone lines. And so there's photos of her apartment where it's basically just stacks of modems and computers and all these wires coming into her apartment. At one point, she consumed every open telephone line in her neighborhood. And so the telephone company at the time, New York Telephone, had to run special lines just to her apartment for all the incoming calls that were coming into the system. And so the point of telling these 4 stories and talking about these historical hobbyist-built networks is to just kind of remind us that hobbyists have solved some really big communications problems in the past. And not only that, but they did so with an extremely limited set of tools, right? If you think about the kinds of tools that they were using, extremely limited storage and memory, copper telephone lines as the conduit for networking, computers that were not as powerful as today's calculators, let alone the computers that we carry in our pockets every day. It's really, really impressive, the really big problems that these early pioneers managed to solve. So moving forward, I want to talk a little bit about networks today and how they're being used and how they might be used. And so the really big problem that a lot of those early networks were trying to solve has kind of been solved, right? So we figured out how to connect people over long distances quickly, relatively cheaply. So we've solved that problem for a lot of people, not necessarily all people, but there are still a lot of big problems left to solve, I think, where community networks can be really useful. So I think access is the first really big one, right? We're almost 30 years past the advent of the internet now, and not everyone has access to the internet yet. So according to the FCC, 34 million Americans, that's 10% of all Americans, still don't have a quality internet connection at home. And that number jumps to 39% in rural areas and 41% on tribal lands. And so if you think about the huge disadvantages that folks who are unconnected are at in terms of looking for jobs, educational opportunities, economic opportunities, it's pretty staggering, I think, that this many people are still unconnected. But there's a lot of other issues with the internet as well, not just access. So at Mozilla, we like to use this phrase internet health, which is a concept that kind of wraps up a lot of other things that we're interested in. And we have a thing called the Internet Health Report that you can read at this URL if you're interested. But basically, the spoiler alert is that the internet is not very healthy, right? There's all of these issues around privacy and security and surveillance and centralization. And it's interesting to think back to that Howard Rheingold quote, I think, about Usenet. Because when the internet was first built and when people were first using it and first kind of conceiving of how it might be used, we did talk about it like it was a liberation technology, right? We did talk about it in a lot of those same terms. And I think it's really interesting that we don't really talk about the internet that way anymore. Our perception of the internet as something that has kind of, that emancipates people has kind of shifted in the last few years, I think. So thinking about the tools that we have access to today and thinking about some of the things that we can do with networking today, I think it's interesting to imagine, right, how might we solve some of these problems that we have with networks using community wireless networks of the sort that we saw in some of the early histories, right? So how can we provide affordable access to people who don't have it? How can we connect remote parts of the globe that are not currently connected? How can we build communications networks that are more resilient to major disasters? How can we address concerns and expectations that people have around things like privacy and security? So I want to give a few examples of networks that I think are doing this really well today and networks that I think are addressing some of these concerns through technology. So the first one here is called Red Hook Wi-Fi, and it's a network right here in Brooklyn. A lot of you guys will be familiar with the fact that Red Hook is a pretty isolated neighborhood in a lot of ways. It's not connected to the city via the subway system. It's kind of cut off from the rest of Brooklyn by the BQE, and it's right on the water, so it's very exposed. And so during major hurricanes, Red Hook is a neighborhood that has been very vulnerable. And in fact, during Hurricane Sandy in 2012, they experienced some of the worst flooding in the city. And so a nonprofit in Red Hook decided to build a community wireless network there in 2012. And in fact, they built it basically right before Hurricane Sandy. And they built a mesh network, which is a networking topology that's really resilient, right? If you cut off one node, it'll just find another route around it, and it'll find another way to connect. And an interesting thing happened when Sandy hit, which was pretty much all of the commercial networks went down immediately in Red Hook, right? So you couldn't place a phone call, you couldn't connect to a commercial data network. But the Red Hook Wi-Fi network stayed up the entire time throughout the storm. And so it became an incredibly important kind of source of connectivity and information for people who were living in Red Hook at the time. There's a number of other really interesting things about the Red Hook Wi-Fi project. They've pioneered something called the Digital Stewards Program, where they basically hire and train young people from the neighborhood in how to kind of build and maintain and continue to build out the network. And so it kind of provides this model, I think, not just to create a pipeline of talent that can help continue to maintain the network long term, but also gives a kind of buy-in from the community, where the community is kind of helping to build and maintain this network. It's not somebody else from the outside who's doing it. And some of the applications that they've built on the network, I think, are also really interesting. So one of the first applications that was built on top of the Red Hook Wi-Fi network was the stop and frisk app that allowed people in the neighborhood to report if they had been stopped and frisked by a New York City police officer. And so I think this is a really, really great example of a network that's super local and addressing local needs and concerns and doing it in a way that really is kind of hand in hand with the community. The next network is the People's Open Network in Oakland, California, and it's a similar network to the Red Hook Wi-Fi network in the sense that it's a mesh network. A lot of us think of the Bay Area as being kind of the center of power for the tech industry and the center of money for the tech industry, and it is in a lot of ways. But in Oakland, for example, 32% of households still don't have a solid internet connection, and so that's actually higher than the national average. And so the People's Open Network, which is run by a hackerspace called Pseudo out in Oakland, is trying to bridge that gap, and they're trying to get more folks in the Bay Area and in Oakland specifically connected. One of the other things that's interesting about them is they have a focus on resiliency, and so they're hoping that by using a mesh topology, they'll be able to keep the network up and running in the event of a major seismic event or something like that. So kind of similar to Red Hook Wi-Fi in that way, it's a disaster-resilient network. And the last kind of present-day example I want to talk about is Guifi, which is a network in Catalonia in Spain. And so Catalonia is a region of Spain where there are many kind of fairly rural places where people live, and small villages and places that are separated by a great distance. It was a region of Spain that was not kind of well served by commercial networks until fairly recently. So there was an engineer in Catalonia named Raymond Roca who decided that he was basically tired of waiting for the big telcos to come and connect his region. And so he decided he was just going to build it himself and build his own network. And so he was taking a vacation in California, and he just happened to buy a bunch of Linksys routers and take them home with him. He cracked those routers, he installed open firmware on them, and he started building out a mesh network. And from that, they today have ended up with a network that has 30,000 nodes throughout Spain and throughout the world, in fact. And so starting with a really, really small scale, almost kind of like prototype network, the folks behind this network were able to build something that now provides the primary source of connectivity for free or at low cost to a number of folks throughout the region. So the last thing that I want to talk about is the project that I'm working on, which is called the NSF Wins Challenges. And this is a series of 2 challenges that we at Mozilla are working on in partnership with the National Science Foundation. And so the idea here is over the course of the next 2 years, we're going to be giving out $2 million in funding to innovative community wireless networks that are trying to address some of the problems I was talking about before. And so there's kind of 2 very specific scenarios and basically 2 problems that we're asking people to solve for. And so we've designed kind of 2 discrete challenges to address both of those. So the first one is one that we're calling the Off-the-Grid Internet Challenge, and the idea here is to get people to prototype disaster-resilient networks, right? So in the event of an earthquake, tsunami, hurricane, when commercial networks go down or are overloaded, how can you continue to provide connectivity to people so they have access to things like maps, communications? And this could be as simple as like a backpack with a microcontroller, a computer, a router, and a hard drive. And maybe on the hard drive you've got maps of the region or resources. Maybe you're running a simple messaging app off of there. So this doesn't even necessarily have to be a kind of a network in the traditional sense of a last mile network that connects to the internet or anything like that. It could be something very simple that just allows people to get access to important information in the event of a disaster. The second challenge is one that we're calling the Smart Community Networks Challenge, and this is a little bit more of kind of a traditional community networking challenge. The idea is to get people to look at some of these regions in the United States that are underconnected or unconnected, and that could be due to economic reasons, it could be due to geographic reasons, and to get people to start thinking about ideas for networks that could be deployed efficiently and affordably in those areas that could provide access. And there's kind of one additional twist to this, which is we're asking people to leverage existing infrastructure in those communities. And so that could mean existing networking infrastructure. It could mean things like disused phone booths, which there was a challenge here in New York City around a few years ago. And the idea is how can you be kind of scrappy and build something that's really efficient and really affordable and really scalable. And when we think about judging these challenges, we're not just looking at technical achievement, but there's a lot of other things we're asking people to consider as well. And so we're going to be weighing technical achievement equally with things like affordability and social impact and scalability. We're also asking people to think about things like privacy and security. We're asking people to actually really deeply think and engage with the communities that they're building these technologies for, with the hope that they'll be building them with the community, not just for the community, and kind of really taking into account the concerns and considerations that members of the community have around using networks. And the overall goal here is, we're hoping that we'll ultimately be able to support the development of networks that are kind of ready to be implemented in real communities and ready to make a real difference. And so, we don't just want to kind of like give away a bunch of prize money and have that be the end of the story. We would much rather have prototypes and networks that are kind of well positioned to actually be deployed in communities and make a real difference. And so to that end, we're kind of designing the challenges in that way. And so the pathway for these is, the first step of the challenges is basically a design proposal where we're asking folks to kind of think through some of the design challenges that would be involved in building these things before they even build anything or prototype anything. And then we're going to be choosing some folks who do an outstanding job at the design stage and kind of moving them on to the working prototype stage and asking those folks to build working prototypes. And then at the end of the challenges, we'll have kind of like a demo showcase for some of the finalists to come and actually demo the technologies they've built and to allow folks to kind of get hands-on with them and test them. And so we're going to be giving a number of prizes throughout the competition, and so there's going to be prizes of up to $60,000 just for outstanding designs, and then prizes going up to $400,000 for outstanding achievement in the working prototype stage of the competition. And we're kind of just at the very beginning of the cycle for these challenges, so we're kind of just before the first deadline, and we actually did have one deadline before that, which was a couple days ago, which was something called the Intent to Apply form. It's a form that you basically fill out just to let us know that you are going to apply to these challenges. But for folks at this conference who might have an idea or might be interested in participating in these challenges, we've actually decided to extend that deadline through the weekend. So you have through Sunday night, basically, to fill out that form. And that form is really simple. It's just like your basic contact info and things like that. So for anybody who has an idea who might want to submit somebody to these challenges, maybe some of the folks who were in the off-the-grid workshop, that seems super relevant to the first challenge. Definitely check out our website where you can find way more information about the challenges and the requirements and all those things. It's just wirelesschallenge.mozilla.org. And if you click the apply button there, that'll take you down to the button to the form where you can fill out the form and let us know that you want to apply. And there's also a link there to our application guide, which kind of walks you through the whole process of applying to this thing. So in closing, I wanted to show you guys this map of Usenet. This is from 1986. And, looking at the map, we can see that Usenet is not, it was not a truly global network in the way that the internet is today. It did connect to some points outside of the United States, but they were very limited, and mostly in Europe, Japan, Australia. But I think it's important to kind of appreciate that this is still a massive achievement for a network that was built 100% by hobbyists, volunteers, on their own time, in their spare time in 1986. And I think it's just kind of a great reminder that hobbyists, volunteers, activists, all sorts of people built some really incredible networks in the past, and I think they will continue to do so in the future. Thank you.